Hello everyone. Big video here on mole calculations. All right, might be a little bit longer than normal, but I want to go over several of the mole calculations so you guys know what I'm talking about here. Well, if you remember mole calculations, there are actually two equalities we have to turn into conversion factors. We did a lot of talking about conversion factors last chapter with the metric conversions. So don't forget, 1 mole of anything has 6.02 times 10 to the 23rd particles. And those particles could be atoms, those particles could be molecules, or they could be ions, okay? Any one of those. Now, again, 1 mole of any substance has 6.02 times 10 to the 23rd, but that has a mass. We call that the molar mass, okay? And if you remember, the molar mass is grams, right? It's actually grams per mole. Now, again, whenever you look for grams and you have molar mass, mass goes with grams, you look on the periodic table. Okay, remember that, the periodic table. Anytime mass is asked for or given, you need a periodic table to find the molar mass. Okay, now have a periodic table out in just a little bit. Actually, have it out now. You can look it up online. You can have it on your computer or your phone. Okay, because I'm going to reference that actually quite a bit. So here we go. We want to convert grams to moles. Okay, so I have 3.80 grams of copper. Dot line, yes, dimensional analysis, huge here. So what I need to do is I need to take grams of copper, I need to cancel that out, and I need to end up with moles of copper. Now, for now, until way along in this course, you're always going to put a 1 next to the copper, 1 next to the moles, excuse me, one mole. It's always 1 mole. Why? Because that was our definition. Let's go back. It's 1 mole, it's 1 mole. So 1 mole is this many particles, 1 mole is this molar mass of the substance. Okay, it's always 1 mole. It's always 1 mole, it's always 1 mole. Just remember that. Okay? Now, mass is mentioned. I just told you, if whenever you have mass mentioned, you must go to the periodic table and find copper, and copper is the element Cu. It's actually element number 29, but it has a molar mass of 63.5. Notice I'm using 3 numbers. Always use 3 numbers. 63.5. Okay? So that's the number on the periodic table. So I'm going to put that there. That's the molar mass of copper. Now, just like we did before, whenever you have a number on the bottom and 1 on the top, you're going to divide. So 3.80 divided by 63.5 is 0.0598 moles of copper. Okay? So that's how we calculate moles. Let's jump down to the bottom one. I'll do more in class. Let's do 7.99 moles of sulfur. All right, so now I'm going from moles. Let's see here. What do we do first? Yeah, mass to moles. This is moles to mass. 7.99 moles of sulfur, dot line. Now I want to go from moles to mass. So the last problem, we were given mass, and it asked us to solve for how many moles is that. This one, we're given moles. Now we got to convert that to a mass. So again, mass is mentioned, so we need a periodic table. Moles of sulfur here, so what goes on the bottom? Moles of sulfur. How many? It's always 1 mole for now. It's always 1 mole. It's always 1 mole. I shouldn't say that. It's 1 mole for now. 1 mole for now. Sulfur has a molar mass. You need a periodic table to look this up. It has a mass of 32.1. Notice I used 3 numbers. Okay, I rounded up to, it's actually 32.065. I rounded up to 32.1. So moles of sulfur cancels out with moles of sulfur. I'm converting to mass. That's on top. That's good. So 7.99 times 32.1 gives us an answer of 256 grams of sulfur. Okay? So that's conversion from moles to mass and mass to moles. Very important. Now, let's go from, let's use the number of atoms. Let's use Avogadro's number. Now, I'm going to talk about how to enter Avogadro's number, 6.02 times 10 to the 23rd in your calculator, but just go with it for a second. Let's do 2 problems on this page here. We're going to take 2.5 moles of carbon. How many particles is that? What number of atoms is that? So if I have 2.5 moles of carbon, moles of carbon here, moles of carbon here. How many? 1 for now. Always put 1 for now, okay? But it asks for a number of atoms. And anytime, here's a nice tip, anytime atoms, molecules, or ions are mentioned, use 6.02 times 10 to the 23rd atoms, and yes, you need to write out atoms, of carbon. Okay, now in your calculator, and I'll go over this in class, you're going to take 2.5 times 6.02, oopsie, 6.02 times 10 to the 23rd. And you get 1.51 times 10 to the 24th. That's 1.51 times 10 to the 24th. Again, in class, I'll show you how to type that in your calculator and how to interpret that, but that's your answer. Okay, so that's moles to number of atoms. Let's go down to this 4.81. Let's go to this one right here. So at 4.81 times 10 to the 24th atoms. Like I said before, anytime you see atoms, molecules, or ions, use 6.02 times 10 to the 23rd. Well, if you have atoms here, atoms goes down here. Again, what number goes with atoms, molecules, or ions? Like I said just a second ago, 6.02 times 10 to the 23rd. We're going to moles. That goes on top. How many? For now, it's 1. So put 1 for now. Now you're going to divide 4.81 times 10 to the 24th divided by 6.02 times 10 to the 23rd. And if you're doing it right, you'll get an answer of 7.99. 7.99 moles of silver. Notice I keep mentioning moles of silver because it's moles of silver. Okay? All right. When we get a little bit more difficult, we'll talk about these types of problems. But that's a good introduction for mass to moles and moles to mass, and then moles to number of atoms and atoms to number of moles. Okay? With questions, email me. I'm going to produce another video that's level 2.